So, you're getting serious about AI, huh? Well, you've probably hit that one massive question. What hardware do you actually need? Let's cut through all the noise. This is your ultimate buyer's guide.
Okay, it really all boils down to this one choice, right? Do you go out and buy your own powerful graphics card, or do you just rent processing power from the cloud? This is the decision that honestly can make or break your budget and your entire workflow.
So here's how we're going to tackle this. First, we'll get into that big cloud versus GPU debate. Then, and this is crucial, we'll focus on the single most important thing to look for when buying a card. After that, I've got some specific NVIDIA recommendations for you. We'll even explore some pretty wild memory options for the power users, and then wrap it all up with a much-needed reality check.
Look, if you're just dipping your toes in and just playing around, cloud services are a total no-brainer. But if you find yourself working on AI projects pretty consistently, then both paths, buying your own hardware or paying for cloud time, start to look like a serious investment. So let's really weigh these options.
And you know, this isn't just about the cash, it's really the classic battle, isn't it? Having total, complete control versus having ultimate flexibility. All right, let's break it down. When you want a GPU, yeah, it's a big hit to the wallet up front, but then it's yours. It's on your desk 24/7. You control everything. The cloud, on the other hand, lets you start for basically nothing and get your hands on hardware that would cost a fortune to buy. But, and it's a big but, you're always on the clock, paying by the hour, and you've got to play by their rules.
Okay, so for the rest of this guide, let's just assume you've made the call. Your AI work is steady, you really value that autonomy, and you're ready to invest in your own rig. The question now isn't if you should buy, but what the heck do you actually buy? Now this right here is where most people get it completely wrong. They get laser focused on speed, on benchmarks, on raw power. But for AI, there's one metric, one little number that trumps almost everything else.
And, you know, before we even get to that metric, we have to talk about the elephant in the room, NVIDIA. Seriously, their CUDA platform is the undisputed industry standard. It's not even a debate. Choosing NVIDIA just means that pretty much any AI code you find online is going to work right out of the box. It's the safe choice, the reliable choice, and honestly, the highest performance choice.
Okay, so you've decided. You're buying an NVIDIA card. You're looking at the specs, you see the clock speeds, the T-flops, but guess what? None of those is the number you should be looking for. The real bottleneck, the spec that will literally define what you can and cannot do, is something else entirely. And that metric is VRAM, video RAM. The best way to think about it is like the size of your workbench. I mean, it doesn't matter how fast your power tools are if your project is too big to even fit on the bench, right? VRAM determines if a model will even load, how much data you can train at once, and how detailed your generated images can be. Trust me on this, more VRAM is always better. All right, so with VRAM as our North Star, let's get into the good stuff. Let's look at some specific NVIDIA cards that give you the most memory for your money. Okay, here are your main options. The RTX 3060. This card is a legend for a reason. It packs 12 gigabytes of VRAM at a really great price, which is perfect for running most of the open source models you'll find and even fine-tuning them. But if you're getting into more serious work, training bigger models or doing high-res image generation, you're going to want 16 gigs or more. And hey, if you're really looking to future-proof, the new Blackwell cards support something called FP4. It's a brand new, super efficient data format that lets you run models faster while using way less memory. It's the next big thing. But what if 16 or even 24 gigabytes of VRAM just isn't going to cut it? What if you want to run those truly gigantic models right there on your own machine? Well, there are some pretty extreme options out there, but just know they almost always come with some trade-offs. And this is the absolute showstopper, Apple's Mac Studio. With its unified memory architecture, you can configure it with an astonishing 512 gigabytes of memory. This lets it run language models so massive they are just flat out impossible on a normal PC. Now the price is, astronomical, but wow, it really shows you what's possible when you completely rethink hardware design.
Now, beyond Apple, there are some other pretty creative routes you can take. AMD's APUs, which are pretty cool. They combine a CPU and GPU on one chip, and they can use your computer's main RAM as VRAM. You can also go treasure hunting for used enterprise cards like the Tesla P40. They offer a ton of VRAM for cheap, but you'll definitely be sacrificing speed and modern features.
All right, we have covered a ton of ground. Let's bring it all back home and talk about what's actually realistic for a home AI setup.
So let's just boil this all down to one single takeaway. Despite all those exotic alternatives we talked about, for most people, for most enthusiasts, the best all-around option is a standard PC with a dedicated NVIDIA GPU. Your target? Aim for 16 gigabytes of VRAM or more, and you'll be set for years to come.
And hey, let's not forget the fun little bonus here. The exact same hardware that makes for a fantastic AI development machine also happens to be an absolutely incredible rig for playing the latest AAA video games at max settings. So really, it's an investment in both your work and your play. Okay, now for that reality check. Your new home PC is going to be an absolute beast for things like image and video generation. I'm talking results that can rival the big online services. However, for things like chatbots and code assistants, while the local models are good and getting better all the time, they're not going to match the quality of a massive cloud-based model like GPT-5. Those systems are running on hardware that is just on another planet.
And that really brings us to our final thought. Can you compete with giants like GPT-5? The answer is no. You can't compete with them head-on. But you know what? That's not the point. The point is that you now have the power to create, to fine-tune, to experiment, and to innovate, all on your own terms. So the real question isn't whether you can beat them. It's what new and amazing things are you going to build.